Myself, Dr. Jitendra Kumar Narwal, Assistant Professor in Chemistry, Janta College, Charkhi Dadri. Today topic is thermodynamics. Thermodynamics, as the name indicates, the two words thermo means heat and dynamics means motion, the relation between the heat and motions. And the different forms of energy can be transformed from one another into. For example, that is the electrolysis, the electrical energy can be converted into the chemical energy, or in electrochemical cell the chemical energy change into the electrical energy, or the heat can be converted to mechanical to operate machines. And it is a branch of chemistry which deals with the study of different forms of energy, and the transformation is known as thermodynamics. There are three laws of thermodynamics and there is no theoretical proof up till now. So first discuss about some important thermodynamic terms, that is the system. System, the part of the universe which is under investigations or observations is called system, and remaining part of the universe which is not a part of system is known as surroundings. And the type of system, three type of system: open system, closed system, isolated system. Open system, a system which can exchange mass as well as energy with the surrounding, is called open system. And the closed system, a system which can exchange energy not mass with the surroundings, they are called the closed system. Or isolated system, the system in which can neither energy nor mass exchange with the surroundings, that is the closed systems. And next some important terms, the macroscopic properties or the macroscopic system. The macroscopic system, macroscopic system means a system containing large number of particles, that a particle, atom, molecule or ion is called macroscopic system. And the macroscopic properties, the property of the system, which arise from bulk behavior of matter, are called macroscopic properties. It is of two types. First is extensive property. The property of the system, whose value depend only upon the amount of substance present in the system, are called the extensive property. For example, the mass, volume, internal energy U, enthalpy H, Gibbs free energy G, a work function, etc. These are the extensive property. Next is intensive property. तो इंटेंसिव से इन जो वर्ड है लेंगे इंडिपेंडेंट, द प्रॉपर्टी ऑफ द सिस्टम, द properties of the system which are independent upon the amount of substance present in the system are called intensive properties. Example, the temperature, pressure, surface tension. Viscosity, refractive index. So many example of intensive properties. Next term is state of system and state variables. State of system, state of a system and state variables. State of system and state of state variables. The state of system means the condition of the system under given set of conditions of its macroscopic properties. When any macroscopic property of the system changes the state of system, state of a system also changes. The macroscopic properties mass, volume, temperature, pressure, Gibbs free energy, entropy, and etc. These are the macroscopic properties. Next is meaning of state variables. State variables. Macroscopic property, the macroscopic properties used to describe the state of a system are called state variables. For example, temperature, pressure, volume or compositions are the state variables. For example, the consider system containing n, this 1 mole gas. For example, in ideal gas equation, PV is equal to RT. Pressure, volume and temperature are independent variables and can be fixed automatically. That volume depend upon the temperature and pressures, and volume is called this dependent variables, or temperature or pressure, they are called independent variables. Next is thermodynamic equilibrium. Thermodynamic equilibrium. The meaning of thermodynamic equilibrium is a system in the state of the thermodynamic equilibrium is one in which the macroscopic property does not change with time, and to reach the state of the thermodynamic equilibrium, the system should attain 3 equilibria simultaneously. The first is thermal equilibrium. A system is said to be thermal equilibrium, that is the temperature of the system remain constant. Second is the mechanical equilibrium. Mechanical equilibrium. A system is said to be mechanical equilibrium if no work done is done by the system from one part to another. This is the mechanical equilibrium. Third is chemical equilibrium. A system is said to be the chemical equilibrium, that is the composition of various phases remain constant. That is the chemical equilibrium. Next term is thermodynamic process. Thermodynamic process. The thermodynamic state of a system can be changed by process, and thermodynamic process is the operation in which the system changes from one state to another. So some important thermodynamic process. The first is isothermal process. A process in which the temperature of the system remain constant, that is dT equal to 0, and heat is exchanged between the system and surrounding is not thermally insulated in this case. Second process is adiabatic process. No heat leaves or enter in the system is called adiabatic process, and dQ is 0. And for such process the temperature of the system varies and heat is exchanged between system and surrounding is the thermally insulated in adiabatic process. Third is isobaric process. बार जो है वो प्रेशर की यूनिट होती है, तो प्रोसेस इन विच द प्रेशर ऑफ द सिस्टम रिमेन कांस्टेंट. फोर्थ आइसोकोरिक प्रोसेस, dV equal to 0. The process in which the volume of the system remain constant, that is called the isochoric process. Cyclic process. A process in which system undergoes a series of changes and ultimately returns to its original state are called cyclic process. And a reversible process, a process in which direction may be reversed at any stage by merely small variables like temperature and pressures. In reversible process, the driving force is infinitesimally greater than the opposing force. That is, it takes the finite time and equilibrium maintained at every state. Next is irreversible process. In this process, the process do not reverse, that is irreversible process, and this goes from one initial state to final state, take the finite time, and the equilibrium is maintained at only one stage, and all thermodynamically naturally process are irreversible in nature. Mode of transfer of energy between system and surroundings, two modes by which the system can exchange energy between system and surroundings. The first is heat. Heat is the quantity of energy which is exchanged between the system and surrounding when they are at different temperature. If the temperature of the system is greater than the surroundings, so heat is lost by the system. Heat is lost by system, and Q is negative. Heat is negative. If the temperature of the system is smaller than the surroundings, so heat is gained by the system. Heat is gained by the system, that Q is positive signs, and the unit of heat is calorie, and when calorie is required to raise the energy of the 1 gram of water by 1 degree Celsius is called 1 calorie. Next is work. This is another mode of transference of energy, and work is said to be performed if a point of force, application of force is displaced in the direction of force, and the work equal to the force multiplied by distance. And there are two types of work. Two types. First is electrical work. Electrical work is important in the system where the reaction takes place between the ions. And second is mechanical work. Mechanical work is performed when system changes its volume in presence of the external pressures, and mechanical work is important in the system which contain gases, and the mechanical work is also known as pressure volume work. Next is expression for PV work, pressure volume work. Consider a cylinder with frictionless and weightless piston. This is a cylinder having area of cross section A. This is the area of cross section is A. This one, cylinder, this one, and this is P external, and this is the area of cross section, and this is displacement dl, and this is P externals. Let the gas having volume V and pressure P contained in the cylinders, and P external, this external pressure acting on the piston. If the P external less than P, so piston move upward, in which the external pressure become equal to the pressure inside the gas. So this is called the expansion, and when piston expand through a small distance dl, the change in volume, the dV equal to area multiplied by dl. This is the change in volume. And pressure is equal to force per unit area, and force acting on the piston F equal to P external multiplied by area. And work done by the system, the force into distance dl, and force ये वैल्यू पुट करेंगे यहाँ पे P एक्सटर्नल इंटू A मल्टीप्लाइड बाय dl. तो वर्क डन बाय द सिस्टम है तो नेगेटिव साइन आएगा, एंड दिस ए डी वेल दिस इज dV, द W इक्वल टू माइनस P एक्सटर्नल दिस dV. This is the work done by the system is negative. If the P external greater than P, अगर एक्सटर्नल प्रेशर ज़्यादा है P से तो पिस्टन that contract in which the external pressure become equal to the pressure inside the cylinders. So this is called contraction, and so we can say the work done on the system, and work done on the system, this is W, the minus P external, this dV, and work on the system is positive, and this the V2 decreased, तो नेगेटिव साइन लेंगे तो प्लस का हो जाएगा W इक्वल टू प्लस P एक्सटर्नल dV. तो यहाँ से दो कन्वेंशन आई, वर्क डन बाय द सिस्टम इज नेगेटिव एंड वर्क डन ऑन द सिस्टम इज पॉजिटिव. Work done, next is work done in free expansion of gas against vacuum. When gas is allowed to expand against vacuum, the external pressure is 0, so W equal to minus P external, the dV, and this pressure is 0, external pressure is 0, so work done is 0. So we can say for in free expansion of gas against vacuum, work done is 0. Next is state function and exact differential. Exact differential. The state function is a thermodynamic property of the system whose change in value depends only upon the state of the system and is independent of the path by which state is reached. So temperature, pressure, volume, internal energy, enthalpy, Gibbs free energy, work function are the state functions. And the path functions may be defined as the property of the system whose change in value depend upon the path followed for the process are called path function, and work and heat are the path functions. Or exact differential, this dH is exact differential, that symbolically we take the U or entropy, this one du is also exact differential, this entropy ds is also a exact differential. Instead of this delta u or this delta s, this is the inexact differentials. थैंक यू। सभी लेक्चर्स को जो है सब्सक्राइब करें।